As you look into the boundless expanse of the universe and observe the sparkling clusters of countless stars, each one seems to quietly ask a profound question that has haunted humankind for centuries. Are we truly solitary in the vast cosmos? Now, a revolutionary piece of technology has been set into orbit, the James Webb Space Telescope, JWST. This marvel of modern engineering acts like an immense magnifying lens, providing exceptional detail and clarity, enabling scientists to uncover the far-reaching details of distant planets. Recently, the JWST turned its gaze to an extraordinary target, K2-18b, a mysterious exoplanet. The initial findings about K2-18b generated a wave of excitement within the scientific community. This celestial body turned out to be unlike any other planet previously studied. Not only did K2-18b show signs of water vapor, which is often linked to the potential for habitability, but it also contained a molecule that piqued the curiosity of researchers, a molecule typically associated with biological activity on Earth. Could this be the momentous breakthrough humanity has long awaited, the confirmation of extraterrestrial life? In this video, we will delve deeper into the nature of K2-18b, exploring the scientific hurdles and profound consequences that this discovery may have, which could redefine how we understand the universe. Let's begin by investigating the first-ever direct image captured of K2-18b, located approximately 120 light-years from Earth. K2-18b is categorized as a super-Earth, and within its stellar system, it is classified as a sub-Neptune, a designation that distinguishes it from anything in our own solar system. This planet is larger than Earth but smaller than Neptune, placing it outside the typical categories used to classify planets. Its unique characteristics present a substantial challenge for scientists as they attempt to decode the many mysteries of K2-18b. While Earth-like rocky planets such as Earth and Mars serve as a base for many hypotheses, gas giants like Jupiter and Saturn offer rough comparisons to help researchers understand distant worlds. However, sub-Neptunes like K2-18b have no direct analogues in our own cosmic neighborhood, making them a fascinating enigma. The data currently available offers some intriguing possibilities. For example, K2-18b orbits within the habitable zone of its star, a red dwarf known as K2-18, raising the potential for liquid water on its surface, much like Earth's oceans. It is important to note, however, that K2-18b's orbit around its star is much closer than Earth's orbit around the Sun. While 1 astronomical unit, AU, is the average distance between Earth and the Sun, K2-18b is situated only 18 cents from its star, even closer than Mercury. This proximity means that a year on K2-18b lasts only 13 Earth days. Fortunately, K2-18b's host star, K2-18, is a red dwarf, which emits less heat than our Sun. This is fortunate, as it prevents the planet's surface from being scorched. If K2-18b were as close to our Sun as Mercury, its surface would likely be inhospitable. In fact, the lower luminosity of K2-18 is a blessing, as it allows for the detection of vaporized water in the planet's atmosphere. This groundbreaking discovery suggests the presence of biological markers similar to those we find on Earth. It's an exciting find that amplifies scientific interest in this exoplanet, which has the potential to radically alter our understanding of life in the universe. Adding to this excitement is the fact that methane, which tends to decompose rapidly under the intense radiation from stars, was detected in K2-18b's atmosphere. The JWST also found carbon dioxide, a more common atmospheric constituent. However, the discovery that really caught the attention of researchers was the presence of dimethyl sulfide, DMS, a molecule not commonly found in Earth's natural environment. DMS is a substance produced exclusively by biological processes. This finding is particularly intriguing because K2-18b orbits a red dwarf star, known for its harsh radiation, which would typically make it hostile to life. Yet, K2-18b seems to defy these expectations. This discovery is especially significant because on Earth, DMS is only produced by living organisms, particularly microorganisms found in our oceans. DMS is known as a reliable biomarker, an indicator of life when detected in a planetary atmosphere. As predicted, the planet would need to be in the right zone, not too close, not too far, from its star, so that the temperatures are conducive to liquid water. A stable atmosphere is necessary, and K2-18b's unique characteristics suggest that the planet could have temperatures similar to those on Earth, though with an atmosphere dominated by hydrogen. This could make its oceans slightly warmer than Earth's, but still potentially habitable. The proximity between K2-18b and its star is crucial. This close relationship prevents surface water from evaporating too quickly, providing an ideal environment for liquid water to remain stable on the planet's surface. This observation is particularly important, especially in light of recent studies suggesting that surface water could be a defining characteristic of potentially habitable exoplanets like K2-18b. In 2021, renowned astrophysicist Niku Mattis, famous for his possible detection of DMS in space, proposed a new category of exoplanets in a fascinating paper published in the Journal of Astrophysics. These planets, known as subneptunes, are enveloped by a thick hydrogen-rich atmosphere. Mattis has coined a new term for these worlds, HIKE, a name that conveys their mysterious and unknown nature. If such planets truly exist, they will be unlike anything we've seen before. Although these water giants could be up to 10 times the mass of Earth and twice its radius, they will not be scorching infernos of steam. Instead, their defining characteristic could be an immense ocean that makes up to 90% of the planet's mass. In theory, such a vast ocean could contain the essential ingredients needed to support microbial life. The dense atmospheres of these planets would trap heat from their stars, allowing liquid water to exist across a much broader range of distances than would be possible on rocky planets like Earth. Subneptunes are relatively common, and worlds like HIKE planets, with their expanded habitable zones, make them promising targets for the search for life beyond our own planet. Larger planets, due to their size, are easier to detect from great distances, making them prime candidates for study by telescopes. Dr. M. Sudan's team used the revolutionary James Webb Space Telescope to observe K2-18b, potentially an alien world, which could be critical in the ongoing search for extraterrestrial life. However, even with such advanced technology, detecting this oceanic world remains a formidable challenge. The key to unlocking the secrets of K2-18b lies in a carefully designed observation campaign, which requires a total of 5 hours of observation, split into 2 separate periods. K2-18b played an essential role in a celestial event known as a transit, where a planet passes directly between us and its parent star. The James Webb Space Telescope captured the light passing through K2-18b's atmosphere during this transit. The beauty of this method lies in the fact that starlight carries a unique fingerprint that provides crucial information about the composition of materials it interacts with. Just as a prism breaks white light into a spectrum, scientists can analyze this light to identify the molecules present in the planet's atmosphere. If certain wavelengths of light are missing from the spectrum, it can provide an important clue about the chemical makeup of the distant planet, allowing researchers to form a more complete understanding of its environment.